Welcome back, my friends, to the lab of arcs and sparks. Let's take a look-see at something. That's my cheap China crap Variac. It had an even cheaper 10-cent, oh man, that's giving him way too much credit. It had a 1.3 cent analog meter on it. So I went on eBay and I bought that digital voltmeter from yet another crap China supplier for probably another 99 cents. And that's my Variac. But you don't care about that. What else have I got? There's my, that's just an industrial amp meter that my son-in-law, Jason, gave me. It's got a toroidal current transformer on board. Just a little module, and you pass the wire of interest through it, and it'll read the AC current. Here, I've got my soldering iron plugged in. You see what it does, okay? But you don't care about that. Total cost, the box was $1.50. The cover plate was 80-something cents, and the outlet was $1. But you don't care about that. I'm in a weird mood. There's my isolation transformer that I built. Once again, a cheap 99-cent China crap voltmeter. It's plugged into the Variac. Interestingly, 120 volts on the input to that isolation transformer results in 113 or 14 out, which is not a surprise since that transformer has several windings, one of which is 115 volts. And since that is primarily used for the restoration of AA5, All-American 5 AM radios, they run on 115 volts, typically. But you don't care about that. As an aside, the core of the transformer is grounded. The outlet is not. It's isolated from ground and ungrounded. But that's not what we're here to look at. God, this is already 3 minutes in. This is what we're going to look at. I'd like to explain what I found. Hang on. This is what I found as was the cause of the missing segments. The first thing I did was raised the board from the chassis to inspect the solder connections, the solder joints, and whoever built this Heathkit did a spectacular job of soldering. Very, very nice soldering. I got lucky. Let me grab another display. Hang on. They are gold plated. They appear to be. I don't know if you can see that corrosion, but I've seen this before on these 1970s era chips with gold plated leads. They're incredibly thin leads. They're just paper thin. And watch me put one right through my finger. And they just, when I unmounted the 5 LED displays, one of them was missing every pin. Every pin was left in the socket except a couple. There were 2 that are fairly good that I tried to fix, but I'm going to show you something else. Hang on. This is the power switch, the on-off switch on the far left-hand side of the front panel. And although this was not causing the problem, the missing segments, once I started moving things around even a little, this wire, this brown wire broke off. That it became unsoldered. And these 2 brown wires are for the our power. They're AC 120 volts. Interestingly, this slide switch, it's a 3-position. When it's in the off position, like it is now, these 2 contacts are closed and none of the others. When it's in the middle position, these 2 are closed and none of the others. When in the right position, these 2 are closed. So this is what they did. They jumpered that pin to that one so that in the middle position it's turned on, in the right hand position it's turned on, in the left hand position it's turned off. So I fixed that. Hang on. Older farts know this to be gospel truth, but some folks may not. On an older piece of equipment, as soon as you open the cabinet, man, let your beady little eyes find the filter caps and look at the end to see if they're bulging out. See that? I don't know if you can tell on camera, but the end of that electrolytic filter cap is bulging out a little bit. So I immediately became suspect of him. If nothing else, check your power supply when doing a resurrection. For God's sake, give it a fighting chance. Hang on. So I decided to start there with that power supply, and my meter set to voltage DC. What do we have? 9.95 volts. That would be obviously to the input of the regulator. Let's see how much AC ripple. Yeah, almost 1/4 of a volt. Boy, am I shaking. Oh my God. Almost 1/4 of a volt of AC ripple. We can safely say that electrolytic has had it. Hang on. The unit architecture that I took a guess at, I was partly right and partly wrong, and I should have known better. But Heathkit surprised me. They did good. Down in here we have our time base and our prescaler section. I believe the prescaler is part of this. I don't think this is all time base. I still have not looked at the schematic, nor do I plan to. I am going to have to look through the owner's manual, the building manual, because there is a disconnected wire that I can't figure out. Anyway, their architecture, these are the chain of decade counter chips right here, and they are original 7400 series logic. These are 7490 decade counters, and they dispensed with the latches. And if you get creative, you can in certain applications, and Heathkit did so. So these are the decade counter string. These are the binary, the BCD to 7 segment decoders. Oh boy. Oh boy. Each of these nearest the display is. Hang on. I don't know why I was thinking flat flex cable, because my son has an embroidery machine that needs one, and I'm having a nightmare time finding it. A lot of medical equipment uses flat flex. Heathkit did not. Heathkit just took the display board, and I thought they would have the builder take a bunch of scraps, a bunch of resistor leads, and solder it to the edge of this board, and then insert those leads through corresponding holes in the main board and solder it up. Thus, and that was classically done on stereo equipment, man, back in the 70s. The display board is at right angle to the main board and connected with a million little wire leads. Heathkit, on this edge, they used metal stakes, so the builder could just snap the stake in place and solder it up. He didn't have to save up his resistor leads. They ran out of a little real estate, so they ran dedicated wires where needed down to the board. Now, hang on. Okay, you'll notice on the two LED displays that I left in place, I tried to fix the contacts on them, but apparently was unable to. But I wanted to verify that it truly is the LED at fault and not the decoder driver chip. So, I'm reasonably sure at this point that it's not a solder connection because I've visually inspected all of them in this area. On these LED displays, these segments are lettered A at the top, B, C, D, E, F. The middle segment is G. This is missing the B segment. You can see my meter on a angle back there, and that's the only way I could get it in the shot. So we're going to see if on this decoder chip, if it's trying to turn on segment G. Okay? When these segments are on, the voltage should go to such a level that it will light the LED about 1.5 or 6 volts. Okay? So here is for segment E, it should be lit. Okay, 1.66 volts. Segment E. Remember now, segment G, I'm sorry, segment B should be lit as well. Okay? Only segment G should be not lit. Segment B should be lit, but it's not. I'm going to go to that pin now. Oh boy. There is segment B. My display's, there we go. Oh, come on, please. Oh, I'm touching the input wire. Which proves it's counting. If I grab that orange wire down there, it'll start counting the noise. Anyway, this segment B, it should be lit. It's not. The 7-segment decoder chip is working. Let's check segment G. That should not be lit, and we know it's not. But just because that LED segment's not lit, given the interconnection, given the problem it has, the intermittent problems, and it's possible that that decoder chip could be defective in trying to light the G segment, but that there's a connection problem. So I wanted to verify that it's not trying to light that segment. And let's see. And there it is. I'm looking at the voltage on the G segment, and it's low. So that decoder driver chip is working normally. The clock is running, which you can tell by the LED. I cleaned the switches, all of them. So I'm going to pause you, and we're going to look at some parts on my computer. Hang on. Okay, I knew I wanted the data sheet for the 7447 chip for two reasons. I wanted to look at the pinouts, and I wanted to look at the package size. That's not true. I wanted to look at the pinouts. Hang on. And so I downloaded the data sheet, and these were the pinouts of the 7447, and that was for testing. But for replacement of the 7-segment display, I figured that they're only available as NOS OEM parts, and I did find some on eBay. As far as NOS prices go, I didn't think they were too bad. Like this one, $7.95 plus $6 for shipping. Well, you can buy several of them and only pay the one shipping fee. And so I thought, okay, well, it's worth $20 to fix it. And then I decided to, and this is for the type part number FND 500. That's the OEM part number. And so I decided to start another instance of eBay, and I just searched on 7-segment LED display. And oh boy, did that turn up some interesting hits. I realized I saw these right here. and visually they're the same. And so I wondered if the pin spacing was the same, and I wondered if they're common cathode, like what I have now, and I wondered if the pinout's the same. Well, I did a little poking around. Now, these displays were made by HP, but then later sold to a company called Avago, which was then consumed by Broadcom. So this part number right here is still a valid Broadcom/Avago part number carried by Mauser, and you can buy these displays at Mauser, brand new. But I did even better. This isn't the one I bought right here. I'm just showing this for an example. I found lots of 10 available for $11 plus $10 plus 6 in shipping. So for $16, I got 10 of these displays, which is enough to replace all of them in my counter, and enough to do another counter as well. A commentor left a comment that, wow, what cool timing. He just bought one too that he's going to repair. Well, mister, if you want 5 free LED displays, leave me a text. Leave a comment. You can have them if you want them, assuming it repairs my frequency counter, and it will. Guaranteed, it will. So I mentioned a wandering wire in the unit. Hang on. And so that's it. That's everything I found wrong. That's the end of troubleshooting. When the parts come, I'll install them, and if there's any other weird surprises, you'll see it again. If not, you probably won't. That's the wandering flying lead, the short orange one, that I've got to look at the manual and try to figure out where it goes. I was going to try to keep this to 5 minutes. There's not a chance. Not a chance. When I do this restoration series on these Heathkits, it'll be a little different. You're going to get a 5-minute, here's my thoughts, right? I'm going to pop the top, and I'm going to take a quick look at above and below, and then record a 5-minute video. This is everything I see wrong with this thing. And then I'm going to restore it, and then have a follow-up video. This is what I did. This is what I found. This is what I think. So I'm going to try my best to keep these to 2 5-minute videos. And I was going to try to do that again today, and I failed miserably. The only thing I succeed at is failure. From the no longer antiquated workbench of N8NK, from the ultra modern LED display filled workbench of Wirehead. Oh my. 73, and be well. Take care of yourselves, your family, your friends, and your critters.